Welcome back to Voltamin. Today, let's talk about CHAdeMO protocol, one of the pioneering standards in DC fast charging for electric vehicles. The name CHAdeMO from charge to move, or the Japanese phrase CHAdeMO ikaga desu ka, which means, how about a cup of tea? Suggesting your EV could charge as quickly as it takes to enjoy a tea break. Developed by CHAdeMO Association, this was the first fast-charging standard ever introduced. It supports only DC charging and uses CAN bus communication between the car and the charger. In this setup, the battery management system acts as the master, while the charging station serves as the slave. Now let's look at the evolution of CHAdeMO versions. The early 0.9 and 1.0 versions focused on reliability and safety. Version 1.1 brought dynamic current control and support for V2H, vehicle-to-home energy flow. Version 1.2 increased power to 200 kilowatts, adding enhanced protection features. Then came version 2.0, boosting charging up to 400 kilowatts, suitable for large commercial EVs and plug-and-charge functionality. And finally, CHAdeMO 3.0, also known as CHAdeMO, introduced in 2021, enables up to a massive 900 kilowatts of power. That's ultra-high-speed charging. So, while newer standards like CCS are gaining ground, CHAdeMO still plays a key role in global EV infrastructure, especially in Japan and early adopter regions. Stay tuned for more electrifying insights right here on Voltamin. Alright, let's now take a quick look at how communication happens between the EV and the charger using the CAN bus in the CHAdeMO protocol. Both the electric vehicle and the electric vehicle supply equipment exchange information through CAN messages, which are basically short digital packets of data. Each message can contain up to 8 bytes. From the EV side, we have 3 main message IDs. 0x100 carries key charging parameters like voltage and current requests. 0x101 shares the calculated charge time and state of charge. That's how the charger knows how full the battery is. And 0x102 sends error signals, helping the system detect and respond to faults. On the EVSE side, or the charger, there are 2 main messages. 0x108, which sends charge parameters back to the EV, such as what the charger can actually provide, and 0x109, which handles error marking signals in case something goes wrong during charging. So, in short, this constant exchange of CAN messages keeps the charger and the EV perfectly synchronized for safe, efficient DC fast charging. Here, let's break down how the CHAdeMO connector and circuit actually work, the hidden communication between your EV and the charging station. On the left, we have the EVSE, or the charger, and on the right, the EV. Between them runs the EVSE charging cable, carrying both high-voltage DC power and low-voltage control signals. Pins 6 and 5 are the DC plus and DC minus lines, delivering the actual charging current. Pin 1 is the protective conductor, grounding both sides for safety. Now the other control pins handle the handshake logic that makes charging safe and coordinated. D1 and D2 are switches on the EVSE side that control the start and stop of charging. On the EV side, F and G are the corresponding signal sensors, detecting those control signals from the station. H is the sensor that checks whether the connector is properly inserted, no connection, no charge. J detects if the vehicle is ready for charging. And K is the final switch. It gives the go-ahead signal for energy transfer once everything checks out. All these safety and control loops ensure that charging only starts when both sides, the EV and the charger, agree it's safe. The moment there's a fault or disconnection, the system instantly cuts power. So, behind that simple plug-and-charge action lies a smart network of sensors, switches, and CAN messages, keeping your EV charging safely and efficiently. We now would like to take a deeper look at this CHAdeMO system wiring diagram. It shows how all the components in both the charging station and the electric vehicle interact during DC fast charging. On the right side, you can see the schematic connections, and on the left, there's a table listing the symbols and their functions. Starting with the charging station, or System A, it includes several key elements. D1 and D2 are switches that send start and stop commands to the vehicle through control pilot lines CP and CP2. J detects when the EV is ready to receive energy. You'll also find devices like voltage and current measurement circuits and a short-circuit protection fuse for safety. On the vehicle side, we have several sensors and switches. F and G detect the status of D1 and D2, confirming communication from the station. H monitors the connection of the charging coupler. It ensures charging only starts when the connector is properly latched. K acts as the final go or stop switch to start energy transfer. And E controls the EV contactors, turning DC power on or off. At the bottom you can see COM1 and COM2. These are the CAN communication lines that handle digital data exchange, like voltage, current, and error signals. There's also a connector lock monitoring circuit, making sure the plug stays safely in place during charging. Together, all these parts form the safety and communication backbone of the CHAdeMO charging protocol, ensuring that charging begins only when both sides agree it's safe and ready. Finally, let's walk through the CHAdeMO charging sequence, how the EV and charging station coordinate step by step to make fast DC charging possible. On the left, we have the EVSE, the charging station, and on the right, the EV. In the center, you can see the digital data flow between them through CAN communication and control signals. The process starts when the EVSE begins loading and preparation. It switches signal D1, letting the vehicle know it's ready. The EV responds by starting CAN communication and defining its voltage and current limits. Next, the charger checks battery compatibility and informs the EV of the possible voltage and current range. The EV then calculates how long the charging session will take and completes its preparation. Once ready, the EV switches K, confirming readiness with signal J, and the EVSE switches D2 to proceed. At this stage, the CAN signal, vehicle charging enabled, is sent. The EV closes its contactors, and the charging station increases output voltage, following the CAN signal, vehicle status. The EV then sends a charging current request, and the station responds with charger status equals 1, meaning charging is active. Finally, when the EV's battery reaches full charge, it sends a charging stop control equals 0 message, and both sides safely terminate the session. This precise coordination ensures every CHAdeMO charging session is safe, efficient, and fully automated. A seamless handshake between car and charger. If you enjoyed learning about how EVs communicate during charging, don't forget to like this video and subscribe to Voltamin for more fascinating insights into e-mobility and electrical technology.